Okay, now let's suppose we've got two functions, f of x equals x squared and g of x equals x minus 3. The f plus g function is defined so that f plus g of x equals f of x plus g of x. Kind of looks like a distributive law, and in this case you do have some sort of distributivity, but you probably don't want to think about it like that. Okay, so f of x is x squared, g of x is x minus 3, so f plus g of x is x squared plus quantity x minus 3. Simple enough. F times g of x, well, what do you think? It's going to be f of x times g of x, okay? And you simply, f of x is x squared, g of x is x minus 3, you get x squared times x minus 3. Now you could expand that to x cubed minus 3x squared, but that's sufficient at this point to write it out this way until you know what you're going to do with it. Now, there's another way to do this, to put two functions together, and that's called composite. We call that f circle g of x. And what we mean by f circle g of x is f applied to g of x, f of g of x. Now, what do we mean by f of g of x? Well, f of g of x is x squared. We've replaced x by g of x, so we have to replace this x by g of x, giving us quantity g of x squared. Then, squaring that quantity, well, g of x is x minus 3, so that becomes just plain old x minus 3 squared. This is a composite of the function x minus 3 and the squaring function. Now we could also do g of f of x. Okay, g of x equals x minus 3. So g of f of x, well, we've replaced x by f of x. So we replace x by f of x, and we get f of x minus 3. And f of x, of course, is x squared, so we get x squared minus 3. And we'll notice that g circle f of x, and I didn't write this g circle f, but let's write it that way. Or g of f of x is not the same thing as f circle g of x or f of g of x. We get something different down here than we get up here. Clearly, the square of this is not equal to this. Now, this whole idea of breaking functions into composites is extraordinarily important. Okay, so, and other combinations of functions, and there's another one, f divided by g of x, and that's just exactly what you would think, and you will have no trouble with that when you see it in the homework.